what we're trying to do is we are trying to get, let's say I gave you a function that looks like this. Start the record yet, right? Let's say I gave you a function looking like this. What our goal is to estimate that root. Okay, that's the objective of this whole class. How do we estimate that root? Okay, so we need to be able to estimate the roots alpha. So we have different techniques that we're going to use to find that, right? You all did it already. Tell me what some of the rules. All right. So the rules will be linear bisection. Then you have a next technique called linear interpolation. I'll give you the formulas and show you how to use each one of them just now. And then the last thing that we have to understand is a technique called Newton-Raphson. Hopefully I spell it right. Okay? But before we use the roots, we need to get an idea of where this root lies. Right? We can't randomly just start here. Right? We have to have an idea of where the root lies. So for example, if I gave you two values, let's say this value here is A, and I gave you this value here is B. How can I determine if a root lies between A and B? I told you, Sunday, right? How you will know if a root lies between two X values? Huh? Yeah, I'll tell you how. I'll tell you something I checked for. There is something that happening on either side of this alpha value. Right. So what you will recognize is that if I come and find f of A, and if I come and find f of B, one value negative and one value positive. So if I multiply them and I get a sign change, it means that definitely that function had to cross the x-axis somewhere. Okay? And that technique is what we call IVT. Right? That is the intermediate value theorem. That's okay? Intermediate value theorem, which basically says, yeah, I'll give you, I'm gonna give that full definition. Right, and I was telling them I will do Sunday this week, I might do Saturday, right? We're going to just practice. Right? You can't practice, need help, just come and I'll come on out. Show you what to do. All right, if you need to start. If you don't, stay home and do your work. Ready? Let's take a small note now. Right, but you all follow what we're doing today, right? Thank you. We have a right, so let's take a small note, just a little note, right? Just a small note. To establish the existence of a root, to establish the existence of a root, that is whether the function touches the x-axis. That is whether the function touches the x-axis. We use intermediate value theorem. Just write IVT, that's good enough, right? We use IVT. right? We use IBT. Full stop. This is the definition for it. If y is equal to f of x, it's a continuous function. If y is equal to f of x is a continuous function, in the interval a to b, in the interval a, write it like this. In the interval a is less than x is less than b. In the interval a is less than x is less than b. Comma. To find if a root exists between a and b, to find if a root exists between a and b, to find if a root exists between a and b, we find f of a and f of b. We find f of a and f of b. Full stop. F of a and f of b. If their product is less than 0, if their product is less than 0, this indicates that at least one root, this indicates that at least one root exists. Right? This indicates that at least one root exists. Okay with that? Right. Here's a slight problem. They don't ask this again, but it's something that you need to know as well, right? Why it is more than one root could possibly exist between here and here? No. Does the function necessarily have to look like this? Can the function between here and here look like this? Yeah, so it could have more than one root, right? So there is a way for us to check and see if it only has one root. Again, I don't see it again on paper, but it's something that you should know. Any ideas? How you can determine if the function only has one root? Think about it. Watch it there. Watch that and watch what it could be. How you could check and make sure that it's not like this, but more like this. F. Right, no, but that's the quite here, so we know. Yeah, that's the entire thing, but we wanted to only have to check out if it only have one root. There's something that we could do. If it looks like this, it could only have one root. But if it looks something like that, we could have 1, 2, 3 roots. Any ideas? Here's what you could do. This function always increases, then, or the function can always be decreasing. You see enough? So if the function always increasing, so if dy dx, I use f prime, right? That's what you will see more. If f prime x is more than 0, and it always increasing, is an increasing function. Or if f prime x is less than 0, it's a decreasing function. So decreasing means it will always be going down. Increasing means it will always be going up. Okay? So if it is an increasing function, if it is a decreasing function, right, it only has one root. But if it satisfies this, it only has one root. Huh? Tell me why is it equal to 0? And there's a flat line. So that wouldn't be either on the axis or it's not in. So a flat line might be like this. If I never touch it, if I never cross the axis. Equal to 0 is no gradient. Okay, so if ever you see it, again, as I said, to take it off, right? Right? So if you could show that the function is more than 0 by just differentiating it, you could show that it only has one root. All right. So normally IVT really, right? Take A, find f of A, take B, find f of B, and work it out. Right, Aaron? The problem is the techniques. I'm going to give you the formula for each one, but I'm going to explain how they do it. Right? Here's how linear bisection works. You have two. Right? You have two. So what they do is they add up A and B and they find the midpoint. So let's say the midpoint is here. What you recognize? You're getting closer to it, right? So when you find C, the problem is we're not sure if it's between C and B or between C and E. So what you have to do, use IVT, right? Take your C, find f of C, and see which one given your sign change. So it will be A. A and C will work. Then you go again, find the midpoint. Now you have D and C. And you keep repeating the process until you get closer. That's okay? Right? So within linear bisection, you're using IVT all the time. So when you add up the two and you find the midpoint, you check and see which would be a two new limits. Right? Linear interpolation, on the other hand, very similar. You're using A and B and you're coming up with a new point C. Doing the same thing. If C might be here and you're using C and B. Use C and B in the formula again, you might get D. And you keep going until you get closer and closer. Okay? Linear interpolation is similar to this. Newton-Raphson, now what Newton-Raphson did, right? Newton-Raphson came up with a formula by drawing a tangent here. You would recognize that the tangent is always very, very close to alpha. So what Newton-Raphson does, it gives you an estimate that's close to alpha, and it allows the estimate to do something called conversion. So the estimate converges to alpha. Okay? So a question will say, use this formula, use linear bisection, you have to follow these steps through it. Use it and so on. That's okay? What you have to learn is you have to learn the formula for each one. Okay? These two incorporate intermediate value theorem. This just follows our iterated process that allows it to get closer and closer and closer and closer. So every time you use the formula, you're getting closer and closer and closer. Okay? So what I want you to do, head up this, write the formula, head up this, write the formula, head up this, write the formula. And I'm going to show you how to start. No, I'm going to. I am going to. And in fact, let me just write this down, linear, interval bisection, interval bisection, interval bisection. Step 1, we find the midpoint, C. Right, interval bisection, step 1, we find the point C, which is the midpoint. Step 2, find f of C. Step 3, establish new boundaries by using IVT. That's this. Establish new boundaries by using IVT. Step 4, repeat until. Step 4, repeat until solutions are the same based on the given decimal places. Step 4, repeat until solutions are the same based on the given decimal places. So if the question say 4 decimal places, you keep going until you get the same answer to 4 decimal places. Okay. Next one, linear interpolation. Linear interpolation. linear interpolation. Right? Find the first estimate, x1. Find the first estimate, x1, using the formula. Just take a look here, please. Right? Of course, you'll recognize what the symbols mean, right? But this is modulus. So if you find f of a and you get -5, you write in +5 here. Okay? We're not using any negative value, only the positive value. Okay? So please pay attention to that, right? We're only using the positive value. Right? Copy down the formula. Online, any questions? Right, step 2, find f of x1. Find f of x1. Step 3, establish new boundaries using IVT. Using IVT. And step 4, 3 is same thing as the last 3. Establish new boundaries using IVT. Step 4, repeat until x to the n minus 1 and x to the n produces the same value. Right? So you basically it should converge, right? As I keep doing it, it's converge. And last one, Newton-Raphson. I have to show you this proof as well, right? Right? Next one, Newton-Raphson. Step 1. Step 1. Use the estimate provided. Right? There's always give you x1, right? So you're using x1. Right? Use the estimate provided into this formula. So if I ask you to find x2, it will be 1 plus 1, which is 2, equal to x1 minus f of x1 over f prime x1. Okay, what does f prime mean again? Differential, right? So it means you have to be able to differentiate here, right? So you have to differentiate f of x. So step 1 is to use the x1 value given into the iterative formula. Again, these formulas are supposed to converge. So if you recognize it going further, like you get 9, then you get 200, then you get 7, you're doing something wrong. Right? You're supposed to get 1.5, 1.43, 1.4. It's supposed to be convergent. Right? So that's step 1. Use x1 in the Newton-Raphson formula. Step 2, right, is to repeat until the same values obtained. Repeat until the same values obtained to 2 or 3 decimal places, right? the 2 or 3 decimal places. Again, it's based on what they give you, right? So let's try a few now. Ready? This is the easiest thing that I'm gonna get. Huh? Probably after the major problem. Right? All you have to do is just remember this. Right? Once you remember, if they say linear bisection, we should follow these steps. I like to use a table method, right? So let's take a look at this here. Let's take a look at these examples. All right. Here we have a fast paper and we're going to use both methods, right? Right? Write it down. Write it down and we're going to do this one here. I don't have it here. It's looking like page 73 in the booklet. Page 73 in the booklet. Oh yeah. Write it down, Emily. Emily, you can mess it up, Emily. You got it messed up, all right? So we're gonna find out something. Copy it down, let's go, right? Copy it down. It's the same function, but just write down what we use in the top. Right? We did it 4 times. Oh, we did it 4 times. Yeah, see that. Everybody got it? Just write the function down. Write the function down and the limits. All your tell me what videos I can do, and I'm gonna just do random. You know, choose your plenty. Do some quick videos on context number or get more share among them. Okay, that's share. How do I full context? Ready? I don't know yet topic. That's just something to show you because you use the calculator. Okay, all right.
Awesome.
Yeah.
Watch this. I'm gonna tell you that I'm gonna take just like this. Scan on watch it.
That's not.
Yeah. You gotta take a stick up by that's.
So you gotta pick one.
You have to pick one. Kill one, marry one, kill one.
Oh.
Yeah.
Oh, okay.
You jump it, so you can choose your front of it to be called. Yeah. Yeah, we can take a right.
Oh, yeah.
That's a fun picture for the education.
After exam, that is what's so like.
So what do you think does after exam?
All right, ready?
You don't want to wait too much.
Ready? So first thing first, IVT, part 1. So all we have to do in IVT, find f of 0 and find f of 1. Really and truly, you don't need the actual value. You just need the positive or negative. Okay, but work it out still. F of 0 easy, right? So this will give you 4 minus 5 is minus 1. We got f of 1 from now. We got f of 1. You can round it off, we don't need, I know it's positive, we just need to know something. Sorry? Sorry? 4 plus 0. Oh yeah, try that quick and we'll again. Find f of 1. 7 points. Alright. Right, so positive, good enough, right? Everybody get up? Right, so now so we say now by IVT, f of 0 by f of 1 is less than 0. Therefore, at least one root. At least one root exists. Everybody feel that? That's the easy part, right? Let's go now to linear bisection. Ready? How many activations set again, Banaya? 3 or 4? 4? Right. Ready? So first thing first, let's find the first limit. So let's find the midpoint. Let's call it C. Add up the two values, 0 and 1, divide by 2. That's a half. Do me a favor, find f of a half. Right? It'll take some time. Somebody had shown me once how to get all the iterations on the calculator. Just plug in one and just keep starting equal and get all the iterations. Can you turn on? I can't remember. I say I'll do a video this year. But fine. But someone from now. Here.
You just Google it.
So f of a half is. Well, I have a quick question. What's the perfect answer to here? 0. Right? If by chance you ever get 0, means that is 0. That won't happen, but that's it. Okay? So Shibish, f of a half is positive. What becomes the new limits now? What will be the new boundaries? Which one you will choose? 0, 1, 0, or 1? This positive. So the next one has to be two different signs. Positive and negative, right? So if this one positive, which one you'll choose? 0. Because it's negative. Right? This negative, this positive. So my new limits are 0.5. That's okay? That's the first iteration, right, Emily? That's the first iteration. So what would we see now, Emily? It will be 0 plus a half divided by 2. These are your new limits, right? So therefore, that will be 1/4. Find f of a quarter, please. And then tell me what are the new boundaries. I should use the word boundaries as opposed to the limits, right? F of 0.261. Oh, we're going back. Oh, 0.261. Okay, nice. So the new boundaries are what? This is positive. A quarter is positive. So we're going to choose the negative. So it will be 0 and a quarter. That's okay? So that's one iteration, two iteration, two more. Yeah, that's the boundaries here. The new boundaries will be a quarter, and since f of a quarter, why use? No, same thing. Boundaries, right? Right, same thing. The new boundaries. Go again and you'll follow what to do. Find the next two iterations. Any questions online? Go ahead, do the next two iterations. Huh? No, the boundaries, the y value, f of whatever, have to be there from the side. Watch here. These are the boundaries to tell us to start with. Both positive, right? Was 0 and 1. But one of them negative and one of them positive. So you want the y value, the f, to be different signs. F of a quarter. F of? Well, right, so that's it third iteration. Sorry. So your third iteration will be 0 plus a quarter over 2, which is 1/8, right? So when you found f of 1/8, what you end up with? Negative 0.44. All right, no matter, negative, right? So what are our new boundaries? Our new boundaries will be, I have to keep this one because that's negative. And which of these is positive? The quarter end. So I will keep 1/8 and a quarter. That's okay. One of them must be positive, one of them must be negative. That's why I choose a quarter, right? 1/8 is negative. 0 is also negative, so I can't choose that. And you all understood why on the diagram, right? Can be on the same side, right? This question said only up till 4. Right? This question said up until 4. Right? So that was how much? 1, 2, 3. One more. One more. So C will be 1/8 plus a quarter divided by 2. Normally, when you work them out and you round off, it getting closer and closer to the same value. Right? How much is this? 3 over 16. So if you find f of 3 on 16, you will get 1, 105. Right? So your new boundaries will be negative and you go with the positive, right? So that's 3 on 16 by 1/4. Right? So after 4 iterations, your estimate for alpha is 360. That's okay? Come on. Right? So after 4 iterations, that's the estimate. Everybody okay with that? Is that better than the others? Watch and see. This is minus 0. This is minus 0.44. Or that 0.2, yeah. So this is the best so far. This is closest is 0. Right? Are you okay with that? That's the way you do technique 1. Linear bisection. Linear interpolation is the same thing, except you have a formula to use now. Okay? Try it now. 3 iterations using this. Right? 3 iterations using this. I wanna try it. So instead of doing this for C, you're doing this long thing here for C. Okay, I'm gonna do this on my right side. So we're doing linear interpolation now, and we already have, f of 0 and f of 1, right? I'm gonna just give you one example. Right, so we're doing linear interpolation. I spelled two bars again, man. So that's called new pronunciation, right?
Thanks. Yeah.
Ph.
Yeah, PH.
Right, so let's get that first estimate there, x1. Right, let's get the first estimate. So x1 will be equal to, again, the old boundaries are 0 and 1, right? So if I use that, this is my A and this is my B. That's okay? This is A and this is B. This is f of A and this is my f of B. Right? So x1 is what? I'm using the formula P, which is 1 by f of 0. F of 0 is -1, so I'm not writing -1, I'm writing +1. Okay? Plus A, which is 0 by f of B. F of B is 7.87. It don't matter, you're going to get 0 anyway. And down here, you're writing f of B, which is 7.87, plus f of A, which is 1. Work it out and you get x1. How much is that? That's 1 over 8 point something. Right, close to 1/8, right? How much is that? Yeah. How much? 0.113. Next, find f of 0.113. We just doing this 3 times, right? That's 1. What's f of 0.113? 0.496. Negative. So you leave it out. It says 0.496 negative. Right? So the new boundaries are what? Right? So you're taking the negative. Always remember, you're taking the negative and the positive. So you're taking 1 and you're taking 0.113. That's okay? You're always taking the positive and negative. Right? So the positive, and we're taking the one that's negative. Go again. Go again, put it out. We are typing regular that as we typing up my money. As we typing up. Oh yeah. 2.37. Yeah, yeah. Kirish, what are you doing on your phone? You hotel? Huh? What you're doing, you're just checking things up. I ain't putting the videos out yet. All right, number one, that was the first iteration, right? So second iteration, that will be, you gotta be careful, huh? This is now your A and this is now your B. Okay? So it will be same formula, B, which is 1 by f of A. What's f of this again? That was 0.4. I write that bad. For what? 496 plus 0 by, it don't matter, right? But I'll still rewrite it. 0 by, no, sorry, not 0. 0.113 by f of 1, 7.87. And then here, you write 7.87 plus 0.496. Right? What you get for x2? 0.166. Anybody get up? 0.166. Somebody online get something there. What is good? Oh. Right? And then you have to find yeah, then you have to find f of 0.166. What's that? Negative again, negative. 2, 2, 3. Nice. So again, what would our new boundaries be? Right? You're taking the negative and the positive. So it will be 0.166. Don't make the mistake and write this up. Right? These are the boundaries. 0.166, the negative value, and the B was positive. Right? This still verify. You recognize that? It's a big boundary still. Right? So kind of fast. So hopefully. Huh? Well, A is A and B is A. Because of the formula, it would make a difference. Right? But ideally, A is the first, B is second. Wouldn't really make a difference because it's positive. If you put or the one first, it wouldn't really affect it too much. But boundaries is always start from the lowest to the highest. Right? So find the third iteration now. That will be B by f of this, which is 0.223 plus A 0.166 by f of A, which is 7.87. This value is so big. That's why it will take real long to converge. 7.87 by 0.223. How much you all got? 189. You can stop there, right? But what is f of 0.189? 0.96. Oh, that's very good actually. So you're getting closer and closer here. Okay? Copy it down so that you stop right there. That's the answer, right? You did 3, we did 3, 1, 2, 3. Let's go again. Here's our answer. You follow okay with that? Let's try and Newton Raphson now. Let's try and Newton Raphson. All right. Forget part C, right? We did one of those already, right? Right. So let's take a look at part D. Part D says that the equation 3e of x is equal to 1 minus 2 ln x is known to have a root between 0 and 1. Okay. Don't let it form confuse you, right? Right, don't let it form confuse you. Just make it equal to 0. Hold on, eh? Right. So if I were to make everything equal to 0, just make everything equal to 0 on that left hand side there, the f of x. Okay, so 3e to the x plus 2 ln x minus 1, that'll be a function. Did that make it look like that to make it look hard, right? Of course, the problem here is you gotta remember how to differentiate, right? So they said taking x1 as 0.2 as the fullest approximation, using Newton-Raphson method to find a second approximation x2. Oh, that's all? Just one? Okay. Yeah, that's one. Right, so watch this here. I'm going to make sure you understand what is f of x, right? So make this equal to 0. So you'll get 3e to the x plus 2 ln x minus 1 equal to 0. That's a function. Okay, this left hand side here is a function. That is your f of x. This is the x1. Okay, so they want you to use Newton-Raphson to find x2. So all we need is this. We need x1, right? Using the formula, right? Look at the formula. We're using x1. Then you have to find f of x1. So you're plugging in 0.2 into the f of x. And then you have to differentiate f of x and then plug in 0.2. And you're working out that. Right? And there's a way to keep clicking Newton-Raphson. Keep clicking equal or something. And you could get all the iterations. Oh, yeah, quiet, yeah. Sit down, let's do all the paper. Take all the time, find this Newton Raphson, just one iteration, right? If you show it minus over, you get that minus or? Yeah. No, average. Ah, no. Two or three decimal places. Most of the time, you want the answer to 2 decimals, so you write it as 3 and wait until it rounds off to give you the same thing. Can I write it right on the thing line? Wait a second. Wait a second. Right, what we got for f of x1? What you all got for f of x1? Negative. Negative 0.555, okay. I just want to make sure you all can differentiate. Should we differentiate that from an place? What's the differential of f of x then? There should be there. Or before that. Right? 3 e to the x, because the differential of e to the x is e to the x, right? And what's the differential of 2 ln x? Here, we'll just say it here. Right now. 2 on x. Right? And the differential of minus 1 is. Right? And then plug in. And then plug in your 0.2 in there. Somewhere again. 13. You got 13.66, right? I can't fit anymore. And then do the division on your done. Do the division on your done. Right, so that'll be 0.2 minus 0.555 all over 13.66. Right, so we shall get 0.0241. 0.0241. Anybody else get up? Yes, sir. So if a question says 3 decimal places, you work with 4, or look at 1 more decimal place, right? And when you round off and get the same answer, then you stop. Everybody okay with that? That's it. This is the easiest thing. It'll be a whole question again because I find it too easy. It used to be a whole question. Yeah. No, two turn. No, cool. I mean, if you're a master, you have a complex number. But look at 0 in a. I'm huh? So where's this from? Yes, estimation. I don't have anything on this. I will do tools again for the online.
It may be without
Yeah.
yeah, nothing.
Oh, I have them. I'm still.
Yeah, nothing for that.
Nice. Actually, reading on the